Okay, this is the P4 paper from June 2021. It's question number 8, which is integration. It's a solving of a differential equation, but obviously we're going to do that by integration, and the method we'll actually use when we get right into it is integration by parts, but let's show where that comes from. So part A says we've got the differential equation dy by dx is equal to 6x y to the third all over e to the 2x. So the way to get going with this is to separate the variables. I'm going to put my dx up here, so all my x terms will be there, which means my y will need to come over, or y to the third will need to come over to the other side. So I'm going to end up with dy over y to the third is equal to 6x over e to the 2x dx. Well, that doesn't look very neat. If I want to be able to integrate that, then that's the same as y to the minus a third dy. It's better. And 6x e to the minus 2x dx. Okay, so now I can integrate. Now, when I integrate this left-hand side, integral of y to the minus a third dy is going to be equal to, that's nice and easy, add one onto the power, divide by the new power. So if I do that, adding one onto the power will make y to the 2/3, dividing by the new power, dividing by 2/3, you can do divided by 2/3, but that's actually the same as multiplying by 3 over 2. If I put my constant of integration in there, then I don't need to worry about having it when I do the other one. In fact, actually no, I'm going to do it on the other one because I'm going to work out the constant of integration on the other side. So I'll leave that as it is to start off with. Now I'm going to worry about integrating the right-hand side, which, as I said earlier, this is integration by parts. Okay, so integration by parts here. Hopefully you've practiced this method a lot, and this should be really, really straightforward to us to go down and do this. What we're going to do is we're going to set u as being equal to 6x, and so du by dx would be 6. We're going to set dv by dx as being e to the minus 2x, and then, no apologies, you have to be able to do this, guys. If you can't do this integral here, minus half e to the minus 2x, you've got to go back and do a bit more basic integration before you come and try these questions. So integration by parts then states that, I always write down the formula, just gives me an anchoring point for my rest of my work. U dv by dx is equal to, and it's uv minus the integral of v du by dx. Just try and show as much method as I think is appropriate. So uv is those two. Okay, so that's going to give me 6x times minus a half e to the minus 2x. Up to you how much you want to do to save yourself some time here. 6x times minus a half is minus 3x e to the minus 2x. I'm just saving myself a little bit of time there. V du dx is minus a half e to the, it's the bottom two, it's these two. And if I multiply those two together, that's going to be minus 3 e to the minus 2x dx, but then I do actually tidy that up and take the 3 out. So that's minus 3x e to the minus 2x plus 3 lots of the integral of e to the minus 2x dx. Quite happy for you to do as much or as little showing of working out as you feel appropriate. Obviously, you don't want to make mistakes, and I think the way that I'm doing it here means I'm less likely to make a mistake as I'm going through. So I've got minus 3x e to the minus 2x, but then integrating this bit, it's exactly the same as we just did. Integral of e to the minus 2x is minus a half. So in other words, minus 3 over 2 e to the minus 2x, and I'll put my constant of integration on here. You don't need a constant of integration on both of them because it would cancel out to make a new constant. That's the integral of that part. So what I now want to do is just to try and tidy up what I'm doing in terms of my layout for the examiner. So all I'm going to do is I'm going to take this part here and just copy it out again. You don't need to do this, I don't think, but I'm just going to put that there and say, right, following on from that then, I would get what the integral of the left-hand side which was 3 over 2 y to the 2/3, is equal to the thing on the right hand side, which is minus 3x e to the minus 2x minus 3 over 2 e to the minus 2x. And that's what we're just saying. You need a constant on one side or the other, but not both. So now we need to get rid of that constant. We need to work out what that constant is going to be. They told me in the question that x is equal to 1, y is equal, x equals 0, y is equal to 1. So if I put that information in, I'm going to get 3 over 2 lots of 1. 1 to the 2/3 is 1. Let's say, try and save ourselves a little bit of time. This is minus 3 nothing, e to the nothing. Well, that's going to be 0 because of the 0 next to the 3 there. Minus 3 over 2 e to the nothing plus c. Remember, anything to the 0 is 1, so we're going to get a value here, we're going to get a value here, but we're not going to get anything there. Anyway, that all tidies up. You can take your time. That tidies up to be that c works out to be equal to 3. And if c works out to be equal to 3, I can then say, okay, 3 over 2, y to the 2/3 is equal to minus 3x e to the minus 2x minus 3 over 2 e to the minus 2x plus 3. Now, even though I haven't mentioned it to you guys, I did already notice that we need to have our answer in that format there. So we're not quite finished. I want to get y squared equals. So if I'm looking at this side here, first thing to do is to get rid of that 3 over 2. So if we multiply everything by 2/3, I'm going to get y to the 2/3 equals minus 2x e to the minus 2x minus e to the minus 2x plus 2. What I've done with that is to multiply everything by 2/3 there. So we're nearly there. I wanted y squared, and I've got y to the 2/3, so I've got to cube everything. To get rid of that third, I've got to cube everything, so I'll get minus 2x e to the minus 2x, e to the minus 2x plus 2, all cubed. I don't see why they didn't actually say show that, because it wasn't going to help me out at all, and it would just give me a little bit of confidence that I'd got that answer right, but that's up to the examiners. Okay, on to part B. Hence find the equation of the horizontal asymptote to the curve with that equation. So if you want the horizontal asymptote, just quickly, I'll spend too long on this, but the horizontal asymptote, imagine the curve is looking something, I don't know what, that's not very, perhaps a curve looks something like that. The horizontal asymptote is that one there. What you can say at this point is that x equals infinity. I like that as a little method for trying to work out the horizontal asymptote. So that's what I'm going to use. I'm not going to put that diagram in. That was just to explain it to you guys. What I'm now going to do, it's only worth 2 marks. So for part B, I'm going to say as x tends towards infinity, y squared will tend toward, you can use equals. I don't think they're going to take any marks off for that. But we've got minus 2 lots of infinity, e to the minus infinity, minus e to the minus infinity, plus 2. You think, well, that doesn't look any simpler. But what does e to the minus x looks like? If you think about what e to the minus x looks like, okay, it does something like that. Over here, e to the minus infinity is just going to be 0. So there's a little bit of knowledge involved in being able to do this one. So let's just say that as e to the minus infinity equals 0, y squared tends towards, so we've got nothing plus 2. And actually, I've forgotten my cubed there and my cubed there. So y squared equals 2 cubed, or equals 8. Y equals 2 to the 3 over 2, or whatever version of that we actually want. And again, we should really say, I guess, y is tending towards, what did it say in the question? Oh no, finally the horizontal thing would be y equals 2 to the 3 over 2, or root 8, whichever way round, depending on what they've got as the answer scheme, but I'm quite happy to have it like that. Okay, hopefully that all makes sense to you.